Okay, in the last lecture we discussed the Fraunhofer diffraction due to single slit, and we saw that the resultant intensity is I is equal to sine alpha by alpha whole square. And then after that we discussed that if we take, instead of one slit, we take two slit, we get the resultant intensity as 4a square cos square beta sine alpha by alpha whole square, where beta is pi by lambda d sine theta. D is the distance between two slits, because now we are having two slits, and alpha is pi by lambda e sine theta, where e is the distance, is the width of the slit. Okay, so now after discussing the resultant intensity, let us try to plot this function in Mathematica and try to see. I also showed you the curves by hand, but now let us try to do it in Mathematica. Okay, so let us take term by term. If I take, so we have two terms in the intensity, cos square beta and sine square alpha by alpha square. Let us try to plot first I cos square beta, okay, and try to see that what do we get. So let us try to plot cos square beta, and now we specify the range of beta as 0 to, let us take 6 pi, minus 6 pi to 6 pi. Okay, also we would like to label the axes, so we will write with comma axis label. Okay, and here I need to specify my, what do I need to label on x-axis and the y-axis. X-axis I need to label beta, comma, and on the y-axis I need to plot cos square beta, cos beta whole square. Okay, so let us try to see what do we get. Yeah, there is some error. Okay, yeah, so here I made a small error. Beta is specified for minus 6 pi to 6 pi. By mistake I have written 0. Okay, so let us run again, shift enter. Yeah, so what do we get? If I plot only cos square beta, I get the exactly same pattern which I got in Young's double slit experiment, and this is what I expect, because the Young's double slit experiment, the resultant intensity is cos square beta, so obviously I should get the same curve. Now, so this signifies, what does this signify? The above term, so we can write format input title. Okay, the above plot signifies the interference between two slits. Okay, so I have two slits and each slit is of width E. So here I have taken the effect of two waves from two slits and I get the interference pattern. So cos square beta signifies the interference between two slits. Now let us try to plot second term. Second term is sine alpha by alpha whole square. So let us plot sine alpha by alpha, sorry, so before alpha also I need to press escape and then at the end escape. Okay, and then in the bracket I'll put square. Now I need to specify the range of alpha, comma, and let us take Now what should I take for alpha? I need to plot on the same curve. So one thing we have to specify that there has to be some relation between alpha and beta, because you see here beta is equal to pi d sine theta by lambda, alpha is equal to pi e sine theta by lambda. So if I take, let us take d is equal to 3e for example. Okay, I am taking the distance between two slits as 3 times the slit width. Then what do I get? From these two equations you can see that beta by alpha I get is equal to d by e. Yes, if I divide these two equations you will get this relation, and from here if I take d is equal to 3e, what do I get? I will get beta is equal to 3 alpha. Okay, so I need to have some relation between d and e, then only I can plot on the same axis. Okay, so now let's, for example, beta I have chosen from minus 6 pi to 6 pi. Let us take alpha from minus 2 pi to 2 pi, minus 2 pi to 2 pi, and then I need to label the axes, label x-axis, y-axis slash alpha, comma, sine alpha by alpha. You can also copy and paste. Okay, there is no need to write again and again, type again and again, whole square. Okay, now let us shift enter. Yeah, okay, so do you see here at the center I get a maxima, and here also in cos square beta I get a maxima, and then so this is 1 2, so pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay, so here I get a curve which we got in diffraction due to single slit, and obviously because in diffraction due to single slit I got sin alpha by alpha whole square. So this above plot we need to give the heading. Okay, the above plot signifies the diffraction due to single, there is a typo, okay, due to a single slit. So you understand what we are heading towards. So we saw that one term in diffraction due to double slit signifies the interference between two slits, and another term signifies the diffraction due to single slit. So basically the diffraction due to double slit is a combination of interference and diffraction. Okay, now if I plot both the terms, then what do I get? Okay, let us see. Plot. So that would signify the diffraction pattern due to double slit. So here I would like, the combination is sin square alpha by alpha square cos square beta. Okay, I would also like to plot sin square alpha by alpha whole square separately. Okay, to show you. So again we have to plot two functions, so I'll make a list. Sin alpha by alpha, okay, whole square, so square, and then comma, again I need the same function, so I will just copy paste. Okay, and I need cos square beta, so I will just copy paste from here. Sorry. slash beta. Okay, I will just cos square beta, command C, and I will type here. Okay, so these two functions I need to plot. Okay, now I need to plot these two functions on the same axis. So I have to use the relation between alpha and beta, and already I know that beta is 3 alpha. So what I will do, I will just remove beta from here and I will write 3 alpha. Okay, now I can happily specify the range of alpha minus 2 pi to 2 pi. Okay, and then because there are two curves on the same axis, I should label them plot legends, expressions, comma. Also I want to label the axis label. Okay, I would like to plot only label only x-axis, okay, by alpha. So you can write like this. Then also I would like to, first I'll show you like this. Okay, so here, okay, there is some mistake because it's showing red. Plot legends, yeah, yes, here one is missing. No, I don't need this. Sin alpha, yes, I need this. Sin alpha by alpha whole square, cos square 3 alpha. Okay, multiply. Let's run and see. Shift enter. Okay, there is some problem, so let us check. Sin alpha, yeah, there is a big problem. I have to write this in the argument in square brackets. Yeah, okay, so now let us try to see. Shift enter. Yes, okay, so we got the plot. Now in order to see this more clearly, I will use one more command, filling axis. Okay, then it will show you colors. Yes, okay, so now you see that my blue color is diffraction due to a single slit, and my yellow or golden color shows the plot of sin square alpha by alpha whole square and cos square beta, where beta is 3 alpha. Yes, this is a combination of interference of two slits and the diffraction due to a single slit. And you can see here that this envelopes the curve, and this interference curve, it goes inside the diffraction. Okay, and we see that how we get the diffraction due to double slit. Once again we run this. Okay, this is interference due to slit, and this plot format, sorry, by mistake I have clicked the wrong window, no, wrong cell. Yeah, axis label, slash L1. Okay, so this I can remove, delete. Yeah, and here comma, I've written one filling, and here axis. Yes, this I can remove. Okay, so now, I was telling that this signifies the interference due to two slits, this signifies the diffraction due to a single slit, and this signifies the above plot signifies the diffraction due to double slit. Okay, so I can just reduce this. Yeah, so this is how in Mathematica you can beautifully see the patterns which we were earlier drawing by hand. Okay, and you can more play with. For example, if now instead of 2 slits I have n slits, which I call as grating, then I can also see that what kind of pattern I will get. And also in Mathematica you can play around with the different parameters of the problem, and you can see that how your diffraction pattern changes with the change in the different parameters. Okay, we'll try to see more in the next video. Thank you.